Thanks for joining me around the virtual telescope. Again, we're going to leave the telescope and we're going to talk about something that's just truly amazing. I saw probably the last news article we'll do for this week. A massive star in Andromeda basically just disappeared. They were expecting it to go into a type 2 supernova, and basically it just disappeared. It collapsed directly into a black hole. So here I just have an artist's rendition of that. For those of us who spend our nights out nudging a telescope or imaging the sky and setting coordinates to image, the Andromeda Galaxy Messier 31 is really an old friend. I know I always go to look for it whenever I can begin to see it come mid to late summer and then through the fall and through the early winter. We know its dust lanes. We know its satellite galaxies by heart. Some of us may even know the visual globular clusters and bright regions that you can see in Messier 31 in a telescope. But while we're looking at the big picture, a massive star in one of Andromeda's spiral arms, M31-2014-DS1, did something revolutionary. It just disappeared. Here you can see images. I've taken it from the article. The link to the article is at the bottom here. So go to EZ Astronomy. You can get all this in depth and go see the article for yourself. Here they image it. This is the area they imaged in each of these things. The star was at the crosshairs in yellow, going from here to there, here to there, here to there. You can see it just disappeared. A new study led by Kisheli D reveals that this star, M31-2014-DS1, was roughly 20 times the mass of our Sun, did go out with the usual bang of a Type 2 supernova. Astronomers were expecting that to happen. Instead, it suffered a failed supernova, where the core collapsed directly into a black hole. It bypassed the spectacular explosion we usually associate with a stellar death. In 2014, the star began a mid-infrared brightening. This wasn't a flare, but it was the star puffing up and shedding its outer layers as the core began to falter. Then in 2016, the star began to brighten in the mid-infrared, a signal that a red transient event was occurring. Then basically from 2016 to 2019, the star's optical brightness plummeted by a factor of 100. It effectively blinked out for visual telescopes. The star located in the spiral arm of the Andromeda Galaxy was a yellow supergiant. In our current understanding of stellar evolution, we typically expect a star between 8 and 25 solar masses to go and end its life as a Type 2 supernova. This star was roughly 13 times the mass of the Sun at birth, but had shed enough mass through the stellar winds to only be about 5 solar masses at the time of its death. Traditionally, scientists don't think a 13 solar mass star is going to collapse directly into a black hole. This discovery, though, kind of points to us that a failed supernova channel for black hole formation is perhaps much more common and occurs in lower mass stars than we previously realized. For observers and astronomers, this is the ultimate now you see it, now you don't mystery. By 2023, deep imaging with the James Webb Space Telescope and Keck's NERAS instrument confirmed the star was gone, which you can see in those images that I posted up above. It was in its place was a faint, extremely red infrared source, only 7 to 8% as bright as the original star. The star had basically vanished from visible and near-infrared detection. It didn't leave behind a bright nebula or a neutron star. It simply left a void, shrouded in a cooling shell of ejected material. That ejected material was the stuff that didn't fall into the black hole. In a successful supernova, a shock wave driven by neutrinos blasts the star's outer layers into space. In the case of M31-2014-DS1, gravity won the tug-of-war here. The core collapsed so quickly and with such force that the shock wave was stalled going out. Instead of being blown away, the stellar material fell inward, fallback accretion, adding mass to the newly born black hole. The 7 to 8% remaining luminosity isn't the star. Like I said, it's the afterglow of material that didn't make it into the black hole. This material formed a rotating disk, kind of like water circling a drain, and a dust shell extending 200 times the distance from the Earth to the Sun around that black hole. We often think of the night sky as static, but this research reminds us that the deep sky is a laboratory of active physics. The study utilized data from the James Webb Space Telescope to detect the faint lingering mid-infrared glow of the dust shell. While we can't see the black hole in our telescopes or through imaging, knowing that a massive star in our neighborhood galaxy has effectively blinked out adds another layer of profound mystery to our next session when we view Messier 31. It's a reminder that every fuzzy pass we sketch or image contains stars on the edge of existence. In the case of DS1, we are witnessing the birth of a singularity in our own cosmic backyard. So the next time you're observing or imaging the G1 globular cluster or NGC 206, think about M31 2014 DS1, a star that was almost 100,000 times brighter than our sun that just a decade ago, and is now a silent singularity. Pretty awesome what the universe can do. Thanks for checking in. We'll catch you next time. Hope you have clear skies. See ya.